Tell me fast. U1 minus what? U1 minus U1 into what? U1 into V1, U1 dot V1 divide by V2 dot V2. Correct? Is it right?
U2 minus U2 into V1 by V1 V1.
So this is U2 na? U2 minus, correct. This is U2 minus U1 dot V1 by V2 dot V2 into what? Into V1 na? Is it correct? What is U2? U2 is 0, 1, 1. Correct? So next minus. So U1 dot. Huh? Yes?
Formula is wrong, ma'am.
Formula is U2 minus
U2 into V1, ma'am.
U2 into V1.
By V1 into V1.
So we are finding U2. U2 dot V1. U2 dot V1 by U2 dot U2. Correct? U2 dot U2, this one.
V1 by V1 dot V1.
1 minute. So V2 is equal to U2 minus U2 dot V1. Correct? Divide by V1 dot V1. This is V1 dot V1, right?
Yes, ma'am.
V1 dot V1 into V1. Correct?
Yes, ma'am.
Okay, now. So U2 dot V1. U2 dot V1 means we have to consider U2 transpose. U2 transpose into V1. U2 transpose into V1. What is U2 transpose? So row matrix of 0, 1, 1 into V1 V1. So V1 is 0, 0, 1. Okay. Divide by V1 in V1 dot V1 means V1 transpose into V1. So V1 transpose is 0, 0, 1 into V1. V1 is 0, 0, 1. So into what? V1. What is V1? 0, 0, 1. So now we have to simplify this. So which is equal to U2. U2 is 0, 1, 1. Right as it is. Minus. Here you simplify this. 0 into 0, 0, 1 into 0, 0, 1 into 1, 1. So we got 1 in the numerator. So next 0 into 0, 0, 0 into 0, 0, 1 into 1, 1, 1 by 1. So into the matrix 0, 0, 1, the column matrix. So 1 by 1 is 1, 1 by 1 is 1. So 0, 1, 1 minus 0, 0, 1. Now subtract the two matrices of same order. 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0. We got V2 as 0, 1, 0. Is it right, V2?
Yes, ma'am.
Okay. Next we have to find out V3. Tell me the formula to find V3. What is the formula to find V3? V3 is equal to U3, na? U3 minus what?
U3 dot V1.
U3 dot V1 divide by V1. U3 dot V1 divide by
V1 dot
V1 dot V1 into V1 minus
3 dot V2
U3 dot V2
by
by
V2 dot V2
V2 dot V2 into
V2.
V2. Okay, now substitute the values. So V3 is equal to U3. What is U3? 1, 1, 1. U3 is 1, 1, 1. So next minus of bracket U3 dot V1 means U3 transpose into V1. Okay, the dot product can be found by using this one. U3 dot V1 means U3 transpose into V1. U3 transpose we consider first. U3 transpose means the row matrix of 1, 1, 1. into V1. V1 is 0, 0, 1. Divide by V1 dot V1. V1, what is V1? V1 dot V1 means V1 transpose into V1. So V1 here we have 0, 0, 1. You consider here 0, 0, 1 into 0, 0, 1. Okay, that's complete into V1. V1 is 0, 0, 1. Okay, next minus U3 dot V2 means U3 transpose into V2. U3 transpose means 1, 1, 1 into V2. Into V2. What is V2? What is V2? 0, 1, 0. Divide by V2 dot V2 means V2 transpose into V2. V2 transpose into V2. 0, 1, 0. Okay. Into V2. What is V2? V2 is 0. Okay, what is V2? 0, 1, 0. Okay, 0, 1, 0 is V2. So next, simplify this. So 1, 1, 1, write as it is. Next, here do the product. So first row, first column. 1 into 0, 0, 1 into 0, 0, 1 into 1, 1. We got 1. Divide by 0 into 0, 0, 0 into 0, 0, 1 into 1, 1. 1 by 1. Into the matrix 0, 0, 1. Next minus. Come to here. First row, first column. 1 into 0, 0, 1 into 1, 1, 1 into 0, 0. So we got 1. Divide by 0 into 0, 0, 1 into 1, 1, 0 into 0, 0. Divide by 1 we got. Into 0, 1, 0. So which is equal to, now simplify. First one is 1, 1, 1. Minus 1 by 1 is 1, 0, 0, 1. Next minus 1 by 1 is 1, 1 into 0, 1, 0 is 0, 1, 0. Now subtract the matrices. So we are getting V3 as 1, 1 minus 0 minus 0 is 1 only. Next 1 minus 0 minus 1. What you got? 1 minus 1 minus 0. 1 minus 0 is 1, 1 minus 1 0. So next 1 minus 1 is 0, 0 minus 0 is 0 only. 1, 0, 0. Is it right, V3? Is V3 correct? Hello?
Yes, ma'am.
Okay. So remember these values of V1, V2, V3. I will go for the next page. Okay. Before going to that, here itself I will find out. Okay. We have to norm we should find, right? First we have to find out W1, W2, W3. Then we have to find out norms for that. So okay, right. So you remember these values. What is the next step? Vinita? What is the matrix W? Consisting of what?
V1, V2, V3.
Okay, V1, V2, V3. Now write down V1, V2, V3. What is V1?
0, 0, 1.
So it consisting of 0, 0, 1. What is V2?
0, 1, 0.
0, 1, 0. What is V3?
1, 0, 0.
1, 0, 0. So this is a matrix W. This is a set consisting of 3 vectors V1, V2, V3. Okay, what next? After finding W, what we should find? So it is called W1, it is called W2, it is called W3, correct? What next? We have to construct R, right? Q na R. What we have to construct next? Q
Q,
or R?
ma'am.
Q. What is the
Q,
matrix
ma'am.
of Q? What is Q? W1
W
by
by norm of
W1
W1.
by norm of W1, correct?
Yes, ma'am.
Next, W2 by norm of W2. Next, W3 by norm of W3. Right? So this we have to find out. So first, since we have W1 here, find out norm of W1. Norm of W1 is equal to, how to find norm of W1? Square root of 0 square plus 0 square plus 1 square. Sum of the squares of the elements of the W1, which is equal to root 1 itself, that is 1. Next, find out norm of W2. Norm of W2 is square root of this element, sum of the elements of W2. That is 0 square plus 1 square plus 0 square. So which is equal to square root of 1, that is 1. Next, norm of W3. Norm of W3 is equal to square root of 1 square plus 0 square plus 1 square. So that is also root 1, that is 1. So now consider here W1. First you write the W1, that is 0, 0, 1. Next, divide by its norm. Divide by its norm is divide by 1, 1, 1. Next, consider W2, 0, 1, 0. So divide by norm of W2, that is also 1. Divide by 1, divide by 1. Next, consider W3. W3 is 1, 0, 0. Divide by its norm. Divide by 1, divide by 1, divide by 1. Okay, next, Q. Therefore, Q is obtained as 0, 0, 1, 0, 1, 0, 1, 0, 0. Is it right, Q?
Yes, ma'am.
Okay. After finding Q, what we should consider? What we have to find next?
R, ma'am.
R. How to find R? To find R, what we should consider?
R is equal to Q transpose into A.
A is equal to QR, correct? R is equal to Q transpose into what? Q transpose into from this itself, A equal to QR, right? Multiply, pre-multiply by Q inverse. So Q inverse into A is equal to Q inverse into Q into R. Okay. So Q inverse into A, Q inverse into A is equal to, what is Q inverse into Q? That is I, right? I into R. I into R is R itself. So R is equal to Q inverse into A. As I told you that you have to check these values also. Okay, these values V1, V2, V3 should be orthogonal to each other. So I forgot to check that one. First itself you have to check, then you go for the W. So what we got V1? V1 is 0, 0, 1 and we got V2. What is V2? V2 is obtained by, what we got V2? 0, 1, 0 na? And V3 is equal to 0, 1, 0, 0. Is it right? Now find the dot product, V1 dot V2. So V1 dot V2, you should consider V1 transpose into V2. That means 0 into 0, 0, 0 into 1 is 0, 1 into 0, 0. So we got 0. Next, V2 dot V3 you find. V2 dot V3 directly also you can find 0 into 1, 0, 1 into 0, 0, 0 into 0, 0. So next, V1 dot V3. So 0 into 1, 0, 0 into 0, 0, 1 into 0, 0. Yes, V1, V2, V3 are orthogonal vectors. So you have to check this one. After finding V1, V2, V3, first you check for orthogonality. Then you can go for W, Q and R. Okay. So if you are not getting 0 means somewhere you did wrong. Please verify it. So as we know that if Q, so Q is obtained by orthogonal vectors V1, V2, V3 only. W1, W2, W3 are obtained by V1, V2, V3. So these are the orthogonal vectors. Orthogonal vectors. So Q is the orthonormal. Q is the orthonormal matrix. Since Q is the orthonormal matrix, Q inverse is equal to Q transpose. Q inverse is equal to Q transpose only when Q is the orthonormal vector. So next, Q transpose into R. So I am going to write, into A. I am going to write Q inverse as Q transpose. Q transpose into A is equal to R that I written here. R is equal to Q transpose into A. Now, so we can find R. R is equal to Q transpose. Here we have Q. Take the transpose of this one. First row is converted as first column 0, 0, 1. Second row is converted as second column 0, 1, 0. Third row is converted as third column, that is 1, 0, 0 into the matrix A. What is the matrix A? Tell me now, what is the matrix A? Vinita?
0, 0, 1.
0, 0, 1.
0, 1, 1.
0, 1, 1.
1, 1, 1.
1, 1, 1. Now do the product of these two matrices. First row, first column, which is equal to 0 into 0, 0 plus 0 into 0, 0 plus 1 into 1, 1. That is 0 plus 0 plus 1, that is 1. Directly I will write it as 1. Next, first row, second column. 0 into 0, 0. 0 into 1, 0. 1 into 1, 1. We got 1. Right? Next, say first row, third column. First row, third column. 1 into 0, 0. 0 into 1, 0. 0 into 1, 0. 1 into 1, 1. We got 1, 1, 1. Is it right, first row?
Yes, ma'am.
Okay, go for the second row. Second row, first column. 0 into 0, 0. 1 into 0, 0. 0 into 1, 0. Is it 0? Is it 0?
Yes, ma'am.
Okay, next second row, second column. Second row, second column. 0 into 0, 0. 1 into 1, 1. 0 into 1, 0. Is it 1? 0 plus 1 plus 0. Is this one correct?
Yes, ma'am. 1.
Okay, next second row, third column. 0 into 1, 0. 1 into 1, 1. 0 into 1, 0. So we got 1. Is it right?
Yes, ma'am.
Third row, first column. Third row, first column is 1 into 0, 0. 0 into 0, 0. 0 into 1, 0. Is it 0?
Yes, ma'am.
Okay, next second row, second column. 1 into 0, 0. 0 into 1, 0. 0 into 1, 0. It is also 0. Is it right?
Yes, ma'am.
Next, third row, third column. 1 into 1, 1. 0 into 1, 0. 0 into 1, 0. So it is 1. Correct? Huh? Is it right?
Yes, ma'am.
So we got 1, 1, 1. So 0, 1, 1. So 0, 0, 1. So now it is a upper triangular matrix. R is the upper triangular matrix. Yesterday also we discussed that we will get R as the upper triangular matrix. Correct? Huh? Below the principal diagonal elements, the elements are zeros. It is a upper triangular matrix. Correct? Is it correct?
Yes, ma'am.
Okay, what is the last step? What we should consider? Consider What we are writing? What is the question?
A equal to QR.
So write the result in the form of A is equal to QR. That's it. So write the matrix A. What is the matrix A? What is the matrix A? 0, 0, 1, 0, 1, 1, 1, 1, 1. This is the matrix A. Can be written as factors of two matrices. QR. What is Q? What is Q? 0, 0, 1. So then 0, 1, 0, 1, 0, 0 into R. 1, 0, 0, 1, 1, 0, 0, 1, 1. So this is the final step. We can write A as a product of two matrices. If you multiply these two matrices, you will get back to this one. Can you check? First row, first column. 0, 0, 0, 0. As you will get 0. Next. See, this is a lower triangular matrix. A is a lower triangular matrix. Okay. We got 0 here. First row, second column. 0, 0, 0. As 0 we got. First row, third column. 0, 1 as 1. Second row, first column. 0, 0, 0. 0 only. Second row, second column. 0, 1, 0. 1 only. Okay. Second row, third column. 0, 1, 0. 1 is correct. Next, third row, first column. 1, 0, 0. That is 1. Correct. Third row, second column. 1, 1 only. 1, 0, 0. 1. Third row, third column. 1. Remaining is 0. It's very fine. Right? Did you clear? Did you clear factorization method? This is pure factorization by Gram-Schmidt method. Okay? Is there any doubt? Is there any doubt? Is all of you clear?
Yes, ma'am.
Okay, right. So that completes your syllabus. So module 4 is also completed. So what we discussed in module 4? What we discussed in module 4? What's the first concept? You see? 1, 1, 2, 4, 2, 4, 8. 1, 2, 4, 4 to 8, 2, 4, 8.
2, 4, 8.
2, 4, 8. So this is a first pivot element, right? Make this element 0 first. So R2 changed as R2 minus 2R1. Next, it is equivalent to no change in the first row, 1, 2, 4. Second row, change the second row, multiply first row by 2. So 2 minus 2, 0. 4 minus 4. It is 0 only, correct? Next, 8 minus 8, 0. Is it right?
Yes, ma'am.
Okay, this is the first pivot element. Second pivot element should be this one, but it is 0, right? Only one column containing the pivot element, that is our basis. Okay, now, so what is the column space? Column space of A is only 1 and 2. Okay, 1, 2. The space, the element which containing the pivot element, the column which containing the pivot element, that spans the whole matrix A. Okay, so this is a basis. 1, 0 is the basis. Okay, similarly you find what we have to find, next null space we have to find. How to find null space? Null space is the solution space. Null space is the solution space. You find the null space. You have to consider the row reduced echelon form in the form of a homogeneous system of equations. So that is 1, 2, 4, 0, 0, 0. So into, so x1, x2, x3 we should consider. x1, x2, x3 we should consider is equal to 0, 0, 0. So next, first row, first column, x1 plus 2x2 plus 4x3 is equal to 0. So actually, as we know that, so here we are considering x1, x2, x3. Since the column containing x1 have only pivot element, the columns containing x2 and x3 does not contain the pivot element. So x2 and x3 are the free variables. x2 and x3 are the free variables we have to choose for it. Correct? We have to choose for x2 and x3 both. Let x3 is equal to k1 and x2 is equal to k2. We have to choose for the two free variables, okay, k1 and k2. Therefore now x1 become x1 plus 2 x2 is k2 plus 4 into x3 is k1 is equal to 0. Therefore x3 is x1 is equal to minus 2 k2 minus 4 k1. So this is x1. Therefore the solution spaces for x1, x2, x3 is equal to x1 is minus 2 k1 minus 4 minus 2 k2 minus 4 k1 and x2 is k2 and x3 is k1. So this is the solution space what we have. Correct? After null space what we have to consider? Row space. Row space is the column space of A transpose. First you find out the A transpose. A transpose is what? A transpose is 1, 2, 4, 2, 4, 8. 2, 4, 8. Now this is the first pivot element. Make these two 0. So can you do like this? Hello? Vinita? Vinita? Did you clear? No?
Yes, ma'am.
Are you getting or what?
Yes, ma'am, I'm getting.
Make these two 0. Okay. So next, this is a first pivot element. So next pivot element should be this one. If it is not 0, make this element 0. Correct? Make this element 0. Actually, to find the solutions, above the pivot elements, we have to make 0. Only one pivot element we got. Correct here? To find the solution space, above the pivot element, we should make it 0 if it is the pivot element. It is not the pivot because it is 0. So for that, I written in the equation form as it is. So next, make these two 0. So next to see this element, actually this element should be pivot element, next second pivot element if it is not 0. If it is not 0, so make below the pivot element and above the, to find just column space means no need to make above the pivot element 0. Okay, I will continue here. Make these two elements 0. So R2 changed as R2 minus 2R1. R3 changed as R3 minus 4R1. 4R1. Okay, next. A transpose is equivalent to no change in the first row 1, 2 as it is. To change the second row, multiply first row with 2. That is 2 minus 2, 0. 4 minus 4 is also 0. So next, make the 4, this element 0, multiply first row by 4 into 4 into 4. So 4 minus 4 is also 0. Here also 4 minus 8 is also 0. Only one pivot element. Next pivot element should be this one. It is already 0. Okay. So next, this is a basis. This is a basis for the matrix A transpose. This is a basis. Okay, right. So rank of the matrix is 2. Rank of the matrix is 1 actually. Rank of the matrix A transpose is 1. Okay. Then what? This is a basis 1 0 0. Basis is 1 0 0. 1 0 0. Okay. The column which containing the basis, that is column which containing the pivot element, is the column space of the matrix A transpose. Here first column containing the pivot element, therefore column space of the A transpose is 1 2 4. Okay, so row space is 1 2 2. Write in the row form 1 2 4. Okay, first row of the matrix A. First row of the matrix A is the first column of A transpose. That's it. So similarly, find left null space. Left null space is null space of A transpose. So basis we are finding. See, basis for the column space, that is row space, the basis is 1 0 0. For the column space, the basis, what is the basis? 1 0. This is the basis. This is 1 0 is the basis. So they are asking us to find the basis. So basis is 1 0. So here basis is 1 0 only. For null space also basis is 1 0. So next, for left null space, first you find out A transpose. Already here we found A transpose and we reduced to the row reduced echelon form. You consider this one only. So A transpose is equivalent to 1 0 0 2 0 0. So first column one variable x1, second column another variable x2. So but this first column containing the pivot element, second column not containing the pivot element, therefore x2 is called a free variable. X2 is called free variable. So we have to assume the value for x2. Okay, now consider in the matrix equation form 1 2 0 0 0 0 into x1 x2 only. X1 x2 is equal to 0 0. So first row first column 1 x1 plus 2 x2 is equal to 0. Second and third equations not existing. And as we know that x2 is a free variable because the column containing x2 variable does not contain the pivot element. Therefore, we have to choose for x2, say x2 is equal to k1. Since x2 is k1, so this equation becomes x1 is equal to minus 2x2, that is x1 is equal to minus 2k1. So therefore, now write in the solution form, the solution matrix x1 x2 is equal to x1. What is x1? Minus 2k1 and x2 is what? x2 is k1. You can take k1 common. So minus 2 and 1. So therefore we obtain the left null space as k1 times minus 2 1. Is it clear? And this is the basis for the null left null space. Did you clear?
Yes, ma'am.
Okay. Next problem Manoj Dev asked that question. Manoj Dev, I will solve that problem and I will send to you. Okay. Manoj Dev.